recording, so I'll do a quick, we'll finish up chapter 3. Next week is our first exam, although everybody's here, so I guess we don't, but I just like to have things recorded too if someone missed. What I want to show you is that there's actually already review tests in Canvas. They've been there since the beginning. So the practice exam for exam 1 and solutions, there is a practice test just for chapter 1, and it's got an answer key, which is a video where I work through the problems and I talk you through it. So it's not just the answers, but it's how to get there and why. Then there's a chapter 2 and 3 practice test. So I combined those into one, a video to work through it. So questions 1 through 3 and then 4 through 10. And that'll be similar to what the exam itself will be like, right? Because how many questions are we going to have on the exam? 15, about 5 from each of the 3 chapters. Okay, and so there's those you can download the practice exam, and I do have one for chapters 1 through 3, so multiple types, so chapter 1, chapter 2 and 3, and then chapter 1 through 3. So plenty of things to take a look at, solutions and answer keys. And when we come back next week, those are the types of things we'll be looking at, working on, and going forward. Then we'll have our first exam. So if you've been doing the homework, if you finish up the homework, questions on the exam will be similar to those, so you won't have any surprises, and you'll see that reflected in the practice exams that are already posted. I may actually find the one I used in spring and post that if I haven't already done that, just to give, again, multiple things. You don't necessarily need to work through all of them. If you go through them and you're able to look at a question and say, oh, I know what that is, I know what that is. The goal is that when you come to the test, it's not a surprise. It's like, oh, I've seen this thing before. I've seen these questions before. I know how to answer them. That's my goal. Okay, so let's go ahead and take a look at section 3.3. Measures of position. So remember, we talked about yesterday, just a quick review, standard deviation. And with standard deviation, we were building off the mean. When we use the mean is the arithmetic middle of a set of data, and standard deviation, what we thought is the variation. And so you can add and subtract that standard deviation from the mean to get an idea of how spread out the data is. Okay. Does anyone remember what percent of the data is between one standard deviation below to one standard deviation above the mean? Good call. That's from the mean to one standard deviation, and so there's 34 above, 34 below, for a total of, you got it. So, and again, that's if we go back in the same slide deck, that's this slide. So that's when we're using the mean and the standard deviation. We'll look at that picture. In this section, we're going to be talking about the median, which is also called down here, if we talk about quartiles, is the second quartile. So what we're doing now, when we do the median, is we're thinking of our data. We've got the smallest piece of data. We've got the biggest piece of data. So we'll call this the minimum, this the max. Where's the median? In the middle. Good. So yeah, we don't know exactly, right? Because we don't have a scale here, but the median's halfway, half the data is below, half it's above. It's not always symmetric, but if it were symmetric, it'd be like here, right? And then all we're going to add into this is two, sort of think of them as 2 more medians. We're going to call them quartiles because you're going to take this bottom half of the data from the smallest piece to the median. You're going to cut that in half. And we're going to call that the first quartile. Okay, so that's this one here. I like to think of it just it's the median of the bottom half of the data. So you cut the data in half, you cut the halves in half, right? Easy to do. And then we do the same thing with the upper side of the data. We go from the median to the max, we cut that in half, and we call that the third quartile. So that means the median can also be called the second quartile. So there's three quartiles, that the cuts, but that divides the data into four pieces. What percent is a quartile? 25%. So this is a part of math, is it's sort of fits, right? Quarter's 25 cents of a dollar. A quartile is 25%. So what we'll find is that there is 25% of the data is in each of these quartiles. So there's 25% in here, 25% in here, 25% in here, and 25% in here. We're going to see that this when we use this box and whisker plot. So we put these on a scale. We make the first quartile to the third quartile a box, and then we make from third quartile to the max, from first quartile to the min, we make those the whiskers, and we get an actual view of how spread out the data is. Okay, so we're going to look at a few of those examples, but remember, we're cutting everything into quarters. We just take the data, cut it in half, cut each of the halves in half, and we've got quarters. So here's an example of some data. What was the first step? If we were going to do this by hand, what would be the first step to find the median? Put them all in order, because it doesn't make any sense if you don't have it in order. So here's it in order. There's 15 pieces of data. It tells us these are the 15 largest US. So that's an odd number. Half of 15 would be 7.5. So there's 7 pieces of data below, 7 above, and they've got these in bold nicely for us. So 31 is the median. And then what we do is, to get the first quartile, we take the bottom half of the data, and notice it's 7 pieces, so it's still odd. So the 26 is our lower median, if you want. So that's the quartile 1. On the upper part of the data, again, we're finding what is the middle data piece, 35, 3 below, 3 above. So that's quartile 3. And then this is what we call the 5-number summary. We've got 3 of them. What are the other 2 numbers? The minimum and the maximum. So you can kind of see, with at least if we have an odd set of data, the 5-number summary itself is actually giving us pieces of the data. It gives us what's in the middle, and it gives us, again, that there's 25% between each of these measurements. Okay. We can also make that into a box plot. And to save us a little bit of time, over here, we can, let me make this bigger. Save us time, I already entered the data, so you didn't have to see me doing that. But then when we go to the top, I'll show you this. If we go to the statistics, it will give us those values, minimum and maximum, 24, 39, we saw those. It will give us the quartiles. Here's our first quartile, which is Q1, 26, 35 for the third quartile. Gives us the median. It also gives us something called the interquartile range, which is the width of the box. But a better way to look at this is if we go to the graph, we can actually do a box and whisker plot. When it comes up, you'll get these choices. Let's see. You go to type, you can do different types of plots. We want to take a look at a box plot. And notice if you arrow through, so it's on the minimum, it says the minimum value. If we arrow to the right, just one, we get the first quartile, which is 26. There's the median. There's the third quartile, which was 35, and the maximum. Now, looking at this, does it look like the data is symmetric? No. Symmetric means the bottom half would be the same as the top. So we cut it in half. This is kind of bigger than that one. Now, it's bigger. Does that mean there's more data in there? Good. No, it's the same amount of data. It just means the data is more spread out. So that's what you have to train your mind to think, because if you're like me, you look at, oh, there's more data there because it's a bigger box. No, it's just a more air in the box. Okay. Same amount of stuff, just more, so, and like this is really small, but there's still 25% of the data there. It's just a smaller set and it's more spread out here. So that's what the box plot gives us, a view of the spread of the data. Okay. It will also give us the 5-number summary. There's a slide in here that shows you how to make a 5-number, how to make a box and whiskers. We're not actually going to have you do that because your calculator will do it for you. But you do need to know how to read a box and whisker plot. Okay, and so we'll look at a few of those examples and go through that, and then we'll get on to the homework. So yeah, let's see, let's go back here. So there's our data. There's the bottom, so 26 is the first quartile. The top half is the third quartile. There's the median. And the interquartile range is sometimes important. It helps us identify whether we have outliers or not. So you take Q3 minus Q1, so that's the width of the box. And there's an official definition of what an outlier is. Remember, an outlier is a piece of data that's like out there. That's why we call it outlier. And the definition, if it's 1.5, 1.5 times the size of the of that box. Interquartile range is big fancy words for the box. Okay, so our box is 9, so 9 plus a half would be about 13.5. So if something was 13.5 larger than the third quartile, if that our maximum was there, that would be considered an outlier. Anything beyond that is an outlier. Okay, or on the other side, below Q1. So if you subtract 1.5 of the from Q1, then that would be an outlier on the lower end. We're not going to spend a lot of time deciding whether we have outliers or not. That's in maybe a more advanced statistics course. Because if there are outliers, then you definitely want to use median. But we're going to teach you the tools. Those type of things are to help you decide which tools to use. But until you learn the tools, it's not very productive to take a look at that. But just know that there is a way to determine whether something's an outlier or not using that. Okay. Box and whisker plot. Again, basically, you just lay out the numbers, the 5-number summary like I did. You connect the 3 middle lines, and that gives you your box. You draw the whiskers for the other one. So something like this, you just do it off of a number line. You could plot each of the points, each of the 5-number summary that you're going to get, and then you can make a box and whisker plot. We have technology. The Numworks calculator will do it for us, so we're not going to worry too much about doing it by hand. But just know that that's all it's doing is you get your 5-number summary. You understand that when you're getting the median and you're getting quartiles, that you're dividing your data in half. You're dividing it in half again. Just kind of visualize that. The way we will actually do it is we won't spend the time to get the data in order and do all that stuff. Because remember, it's a little different if there was an even number of pieces of data and an odd number. But the cool part is if we use the calculator, we don't have to worry about that. It takes care of those details so that we can focus on the meaning of those 5 numbers and not have to worry, spend extra 20 hours or whatever it takes us to get to those numbers. We get the numbers and then we can work on what they mean. Okay. And it's our last slide. I forgot to do this in the other class, so fortunately someone stayed around, did their homework, and I saw there's a few things. So mostly it's quartiles, but there's also something called a percentile. Uh, what do you think a percentile is? Quartile is 25%. What's a percent? How much? Well, how many divisions would a percent have? 100, exactly. So there'd be 99 lines actually up to, yeah, but they're 100. So the percentile is each percent. Uh, so, but when we use the word percentile rather than quartile, what that means is that's the percent that's below. So think about it. The same thing with a quartile. The third quartile means that there's 75% below it. So if I'm at Q3, Q2, Q1, draw my fancy little box and whisker, that I know that 75% of the data is down here. That's a quartile, using the quartile. Right? Percentile is the same concept. It's just that it's the percent below the data. So if I say I'm at the 91st percentile, what does that mean? I'm better than, my score was better than 91%. So that means I was here at 91%, and my score, or whatever my measurement, was 91% better. Now be careful, because I got this backwards when I was a kid. I heard I was in the 10th percentile, and I thought that was really good, so I was bragging to everybody, and my dad said, no, that means you're at the bottom 10. Oh, Dad, I thought I was at the top 10. Oh, well, it was spelling, so I was okay. I'm not a good speller. You might see that. So, okay, I'm at the bottom 10 percentile. So when you're talking percentiles, just remember that whatever number that is, that's percent below you. Now, top 10 percentile, you could say that, and that actually means you're at the 90th percentile, right? Because how many, if you're at the very top, what percentile are you at? 100, yeah. 50th percentile would be about the mean or the median. 100th percentile is at the top. Okay, and so if you're at the 91 percentile, how many percent is above you? 9%. 91% down here. So that's all a percentile does. There's a few questions in there, maybe only 2 of them, that ask you about percentiles. They will ask you like a percent, like what percentile is the median at. We just sort of answered 50 percentile. Quartile 1 is at the 25th percentile. So percentile, when we're using it, is always referring to the percent below. But sometimes we want the percent above, and so we have to do that subtraction of taking 100 minus 91 and finding that there's 9% above the percentile, 91% below. Below. See my spelling. Okay, 10th percentile. Still today. But my 7th grade teacher signed my annual, and she put that I was her most creative speller. I thought that was the best twist on it. So I said, no, I'm not a bad speller. I'm just a creative speller. So always turn it to a positive. That's the important thing. All right, we're done. So I'm going to kick off the thing. You have work on what you need to work on. Have a great weekend, because we're not coming back tomorrow. And we're not coming back on Monday, right? So we got a nice 4-day weekend. Well, you guys probably have other classes on Friday. No? Cool. Yeah, well, it's still good to have Monday off. I'm looking forward to it. Yes. All right. Well, you do whatever you need to do. The college level, this is a college course on a college campus. And so, again, get on your homework. Go take a break if you need to go. Maybe you didn't come back from the break. I don't know. I don't track those things. No hall passes needed in this school. Yeah, do your stuff.